Hi, this is Kevin. Welcome to the tutorial for exercise 1. Uh, and we're working on the coding assignment for Severance chapter 11. This is the chapter on regular expressions. And in this first exercise, we're going to read a text of a novel that I got from Project Gutenberg, and we're gonna look for just one word, and we're gonna count how it appears in various contexts within the novel. All right, so let's begin with the data. From my starter files, I'm going to bring over a data file um, called, let me paste it in here. It's called journey.txt. And it is the text of the novel A Journey to the Center of the Earth by Jules Verne. I got the text of this from Project Gutenberg. You can find a lot of texts there if you'd like to use them for your computing work. And A Journey to the Center of the Earth was probably the first science fiction book that I read as a young person. And it really caught my attention. And so I remember it fondly. And one of the other things I remember is that it's the story of a young man who accompanies his uncle um, on a journey to the center of the earth, hence the name, Journey to the Center of the Earth. And the young man is the narrator, and he uses the word uncle quite a lot, okay? And let's go down, let's get through the front matter of the book, and you'll see what I mean. Okay, so we get to chapter 1, and just the title, My Uncle Makes a Great Discovery. There's Uncle already. Then when we get down to paragraph 2, there's one uncle there. There's another uncle here. And there's just a whole lot of it. So I thought if we had to pick a novel that we could get the text of and we could go and we could count the number of times that uncle appeared, well, that would be worth doing. Okay, so that's what we're going to do. All right, so that's the data. Now, the program, let's create the program. New Python file. And this one is just going to be called My Uncle. Okay. And of course, I already have I have an already big version of this. Okay. And I'm going to bring over parts of it. Now, this is a pretty straightforward design, so I'm not going to do pseudocode. Okay, we're going to read the input file, which has the text of the novel, line by line, and we're going to search the lines for matches to the word uncle using regular expressions, and this should be the kind of thing that you could write these days without having to do the pseudocode first. Okay. So let's see. The docstring says count the number of lines in which the word uncle is found in different contexts. And what do I mean by context? Oh, one context that we're going to use is it in the line at all? Another context, is it at the beginning of the line? Is it at the end of the line? Is it at the beginning or the end of the line, right? So we're going to do those kinds of things. All right, so the first thing we're going to do is we're going to prompt the user. Well, I did one other thing before that. I printed out a polite message about what the program does. Print count lines that contain the string uncle in the input file. Okay. And then I'm going to prompt the user for the file name. We're going to use the path data because what we're doing in our projects these days is we're putting all of the data files in a subdirectory with the name data. And I'm going to open that with encoding UTF-8. All right. Now, what's the next thing I need to do? Well, I said I was going to count things, and so I need to have an initialized counter for each of the contexts in which I would like to count the occurrences of the word uncle. So I'm going to bring over the counters. So I've got line count contain. That'll be a count of whether it contains the word uncle at all. Line count begin, does it occur at the beginning of the line? Line count end, does it occur at the end of the line? And line count begin or end, which is we want a count of the lines on which it's either in the beginning or in the end. Okay, good. And you'll notice that those are all grayed out because we haven't referred to the variables. Okay, so this is just the classic for in to read the file a line at a time. So for line and in file. Okay. Now, one of the things that helps when you're doing this kind of natural language processing is to shift the characters to lowercase such that you won't miss occurrences that are in different capitalizations. Okay. Or, as an alternative, we can use another feature, okay, which is ignore case. Let's use that. The actual code that I have here doesn't use that, but we'll change it on the fly, okay? So let's look at our first batch of code. Okay, well, I'm going to show you what I originally had. All right, let's do this. This is what I originally had. Okay, and I've decided to change it here. So I shifted it to lower. Okay, so I didn't have to worry about the case. Okay, and then I said if I had imported the regular expressions module RE. So we say if RE search, and then I give the regular expression in a raw string, just as I've been teaching you to do in the course. And then I've got the variable line where I'm looking for the match. Okay, and if that's if I get it true for this, then I'm going to bump up the line count contain. Okay, and let me bring over a little bit more of my program, and we'll do it kind of a piece at a time. So when I'm done with all these, I'm going to do a close for in file. So in file close. Okay, we've got that. And then we're going to do some reporting. Okay, so let me bring over the one where we report um, the number of overall lines. Okay, so we're going to report line count contain lines in file contain the target string. Okay, so let's give this a run. All right, and we got a couple problems here. These are always fun. Problem number one is I've got no code at the bottom here that invokes main. So when I ran that, that did absolutely nothing. Problem two is I want to also bring over another possible input file, one that we use pretty often, that empty file.txt. So let me copy that and bring that over here. Okay, because we're going to want to test with that as well. And that's the empty file, which is, of course, empty. Okay, so let's run this again now that we have a call to main. And let's run it with empty file .text. And it says 0 lines in the file contain the target string. Okay, that makes sense. Run it again. Let's do journey.text. That's the name of the file. So 503 lines in the file contain the target string. Okay. Let's go back and look at this. What if we didn't do the shift to lowercase here? I bet some of those 503 lines are not all in lowercase. So let's shift this. Let's take off the shifting. Okay. And then let's just run this again. And we're going to get a number that's lower than, because I know in that, for instance, I know that the title of the first chapter is Uncle in all caps. So that's at least one line we're not going to catch. So let's run this. And let's say again, we want to do journey.text. And it's only 472. Okay. And of course, what we'd like to do, we think this is a better approach, is as the third parameter here, we want to pass re.ignore case. Okay. And so instead of downshifting the file, we're going to include this, kind of modifier flag. You can call it whatever you want. It's this parameter, it's this constant that is part of the RE package, and it's how we tell re.search that we don't want to consider a case. So if we test this again, I'm going to expect it to come back to 503. So let's run with journey.text, and we're back to up to 503 lines, which is good. And better code than I was going to show you to begin with. All right. Okay, so what's the next thing that we can test for? Well, the next thing that I want to try is, can I find uncle when it's at the beginning of a line? Okay. Again, with these regular expressions, we can do that. Okay. And what have we got? Let's space these out so we can see them a little better. Okay, so we've got the circumflex out here, and we're looking for uncle at the beginning of the line. And of course, we need to report that. So let's put another line down here in our reporting. Okay. Line count begin is where we're doing it here. And we're just going to run the program again and try journey.text. And we can see that there are 27 lines that begin with the target string. Very good. Okay. And the next thing we're going to look for is how do we do this if we're looking for it at the end of the string, which in this case is the end of the line. Oh, I know what we forgot to do. We forgot to put ignore case on the last couple things that we put in. That was a mistake, wasn't it? Put ignore case right here. Okay. I bet that's going to change this up from 27. Let's look at what we get. Okay. What did we get? So here we are. We did something. Where are we? You know what we did? We forgot the line. So, my bad. Okay, now they read better. In fact, let's put this newest code into a comment while we test the second test again. Okay, so journey.text. Oh, 27. I knew that was a familiar number, but okay, so that one didn't change. And we're going to do the third one where we're looking for uncle at the end of the line. So we have uncle and then a $sign. Okay, and let's get that running again. Journey.text. Okay, and we probably counted, but we never reported it. So we're going to have to bring over another line for that. Okay. And let's run that again. Journey.text. So 10 lines in the file contain the target string at the end. All right. And then let's look for it at the beginning or at the end. How's that? There we go. Beginning or end. Okay, and of course, we're going to have to bring over one more line of reporting, right? Okay, that looks pretty good. And let's give that a run. And it's journey.text. So let's see what we got. We got 503 lines contain the string at all. 27 lines have it at the beginning. 10 lines have it at the end. And 37 lines have it at the beginning or the end. And that makes sense because if you add the beginnings and the ends, well, then you get the number for the beginning and the end. Okay, so this isn't real sophisticated natural language processing. There are packages for natural language processing that are certainly a lot more sophisticated than this. But this is a way we can read a file and look for strings that we want to recognize, and we can get the RE package to behave the way that we would like it to behave. We've seen this behave as expected. Two features that I talked about in my supplemental lecture. One is that the search method, the search function of the RE package, okay, it returns a value which we can interpret in a Boolean way. Okay, and as I said in the lecture, it's actually a match object, okay? And if we have a successful search, we get back a match object. And with the kind of matches that we're looking for, we really don't have a reason to go examining the match object to sort of analyze how the search ran. But that has a true interpretation if we use it in if, okay? And then the other thing that we can get back is a none object, which will have a false value, okay? So we've seen that behavior that we talked about in the lecture. Oh, and look at this. My ignore case was forgotten here. Wow. There it is. The other thing from my supplemental lecture is this ignore case parameter, which is a real great way to simplify your regular expressions and not have to make them so complex that they include upper and lowercase and all of those things. So let me test this one more time as long as we're here. See if we got 37 lines. Well, we should. Journey.text. And what did I not like about that? Oh, again, I left the line off. I'm consistent. Wow. We're having a slow day here. Okay, let's try it again. Journey.text. And there we are. And we got 37. All right. Okay, so I'm going to turn you loose to work on yours. Yours is going to be different in a couple of ways. We're going to be looking for one further context, and we're going to be looking for a different word in a different document. But really a very similar problem altogether. So good luck on that, and I'll say bye until next time. Bye-bye.